Welcome to Mr. Hamilton's Math Bites. Adding, subtracting, and multiplying polynomials is this lesson. I'm giving you a thumbs up because I think you know how to do this, and this should be a review for many of you. As there's no handout for this lesson, you may want to write everything down and pause the video at different times to do that. Let's recall a couple of things. The first thing we need to remember is that a polynomial expression is a relation with multiple terms. So for example, if we have a monomial, this actually does not have multiple terms. It has one term. Mono means one, so that might be something like x squared. A binomial has two terms. That might be something like 2x plus 3xyz. Notice that x and 3xyz cannot be combined because they are not like terms. And we could have something like a trinomial. Trinomial has three terms. So for example, x squared plus 2x plus 4, which you probably remember is the standard form of a parabola, is an example of a trinomial. The second thing we want to remember and recall is the degree of a polynomial is the value of the highest exponent. So let me give you two examples. 3x squared plus 8x, well, this has a degree of 2, or it's a second degree polynomial, because the largest exponent is x squared. If I have something like x to the power of 4 minus x squared plus 7, that's actually going to be a fourth degree polynomial. Now what we're going to specifically be concerned about here is dealing with only one variable, like x or just y. So there is a case where we have x squared y, that would be a degree 3 polynomial, but we won't usually see that. And again, I just want you to remember that we only combine like terms when we simplify. So 3x times y and 4y times x, these are like terms, but these are not like 7x squared y. Those are not the same terms. So we could combine 3xy and 4yx, and if we added those together, we would get 7xy. But we cannot add the 7x squared y to those two other terms. So let's look at some exact examples of adding and subtracting polynomials. The first one I'll do here is 3x squared minus 4x plus 5, and then we're going to subtract in brackets 5x squared plus 3x minus 2. Most mistakes are made on these types of questions because people try to skip too many steps. So what I'm going to do is I'm going to very intentionally get rid of the brackets first, and then we'll solve it. It takes about 5 seconds longer, maybe 10 seconds, but it's well worth the time. So that negative is going to change the sign of all of the terms inside the brackets. Now I'm going to combine the like terms. And the like terms here, I like doing this by simply circling the terms that are the same, also circling the sign in front of the term. And then I'll use a different symbol for the next set of terms that are the same, and then I don't really need to do much for that last set that are the same. So 3x squared minus 5x squared is negative 2x squared. Negative 4x minus 3x is minus 7x, and then plus 7. This brings us to the topic of equivalent expressions. And really that's just a fancy way of saying that two expressions simplify to the same thing. So let's look at the following. If you had an example that said determine whether f of t and g of t are equivalent, well, you'd wonder, what are f of t and g of t? Well, here you go. F of t is equal to t squared in brackets plus 15t minus 100 plus in brackets 5t squared minus 3 minus in brackets 5t plus 2. G of t is going to be this. in brackets t squared plus 10t minus 110 minus, in brackets, negative 5t squared, minus 5. Well, the first thing I want to do for this is I want to write this out in expanded form, so without the brackets. So I'm going to write f of t, and that's just going to be t squared plus 15t plus minus 100 plus 5t squared minus 3 minus 5t minus 2. Again, that negative changes the sign of everything in the brackets that follows. G of t is going to be equal to t squared plus 10t minus 110 minus a negative makes that a positive 5t squared. And then again, subtracting that negative 5 gives me plus 5. And just for the sake of space and simplicity here, I'm going to add this to the same line. T squared and positive 5t squared gives me 6t squared. 15t and negative 5t gives me 10t. And negative 100 minus 3 minus 2 gives me negative 105. Let's see if g of t gives me the same thing. T squared plus 5t is going to give me 6t squared. You can probably already tell this, but plus 10t, and then negative 110 plus 5 gives me negative 105. So we would say, therefore, these are equivalent algebraic expressions. Well, why did I have to simplify? You might ask that. Why couldn't I have just quickly substituted a number in, and if it gave me the same answer, I know they're equivalent? Well, the reason is because you haven't proven it's always true. You've proven only in one specific case. So you need to simplify if you're trying to show that they are equivalent. If you're trying to show that they are not equivalent, then if you substitute a number in and you get two different answers, then you know that's true, that they're not equivalent. Be careful that you pick the numbers carefully. Because if you don't pick the numbers carefully and you're trying to show something's not equivalent, you may actually be wrong. For example, if I have xy plus xz plus yz, and I have x squared plus y squared plus z squared, and you're trying to show that those two expressions are not equivalent, well, it's pretty clear that the case of xy plus xz plus yz, if I let x be 1, y be 1, and z be 1, well, that's just going to give me 1 times 1 plus 1 times 1, and you see where this is going, plus 1 times 1, and that's just going to be 1 plus 1 plus 1, which is 3. Well, likewise, here we'd have 1 squared plus 1 squared plus 1 squared, and you might be inclined to think, well, that actually means that's 1 plus 1 plus 1 again, which is 3. Those are equivalent algebraic expressions. They are not. Because if instead of choosing those numbers, we decided to choose, let's say, x equals 0, y equals 0, and z equals 1, we would clearly be able to see that xy plus xz plus yz would be equal to, well, x times y would be 0, and then x times z would be 0, because x is 0, and then y times z would again be 0. And so you get an answer of 0. But in the other case of x squared plus y squared plus z squared, you would get 0 squared, which is 0, 0 squared, which is 0, and z squared, which is 1. And so you have two different answers based on what value you pick. So my suggestion in all of this is always simplify to see if they are equivalent. That way you won't accidentally pick a wrong number that actually means that that looks like it's equivalent when they're not